Hey everyone, my name is Patrick and you're watching The Everyday Machinist. In this quick little video, I'm going to talk about fixturing and why I think it can make or break your small CNC job shop, or really kind of sets you apart from a lot of the other job shops that are out there, is your ability to think on your feet and solve problems, because that's pretty much what it comes down to. Most of the job shop stuff, whether you're doing stuff as kind of an independent contractor for other companies, is that every day you're looking at RFQs, you're putting out quotes, and some people lack or kind of slack on thinking, well, I can bid this and maybe run it through one of the online quick quoting softwares and kind of look at it, but what you fail to think about is fixturing. And I think it's pretty critical. If you don't have that skill to come up with something that'll solve your problem, that's somewhat repeatable. Now, there isn't one size that fixtures all, right? So the standard thing is your 6-inch vise, right? I have quite a few 6-inch Kurt vices, and my go-to for those is a soft jaw, an aluminum soft jaw. And I've made so many of these. And the cool part about that is we can kind of machine them to have just more of a flat backstop for basic raw stock stuff, right? So we have that. It is actually 2-inch by 3/4 aluminum 6061, and I wound up machining an oval in it. Now the Kurt vise comes with a socket head cap screw that recesses into their hard jaws. It's kind of a pain, chips get caught in there and stuff like that. So from McMaster, and I don't have the part number on me, but these are a little bit pricey. I think they're about $5 a bolt, and I have a lot of them. But it's a shouldered bolt. Hopefully you can see that. And with it being somewhat of a precise hole, it kind of allows repeatability with installing your soft jaw. So if they have to come out for some reason and you need to move them on either side of the vise, you can do so. And it's kind of, it's nice having these. You do throw them away after a while. Oh, and why I oval it, I can also flip it. So there's really, I can use, 4 sides of this, technically 4 sides of this soft jaw if I wanted to. So, and doing soft jaw stuff, you get into stuff like this. So this is a very specific soft jaw that we machined here for a particular aerospace part that we do, with some third op stuff that we do on this. So those are really nice, and they're pinned for location. And also we laser engrave the part number and rev number on them, which helps us tremendously with that. So that's very basic when it comes to a 6-inch vise or any kind of vise that you have for soft jaws. This is my go-to soft jaws. Repeatability, I guess, is there if it's just a standard soft jaw, where you have machined a certain critical step into it, and so forth. So moving on, this is a very specific fixture, okay? And again, it's your level of creativity and your kind of forward thinking and looking at the job and really figuring out what you need to do to get the job done. It's difficult. I've struggled with it. And what's the best fixture for the job that you have to do? So it's just a matter of kind of really breaking it down in your head and kind of 3D'ing it in your head and thinking, well, what's the best way to hold it? So that's why I feel it could be a make or break, because you could have a bunch of these. You throw them out all the time. I've had so many of these where I've just machined radiuses in them and steps, and I've actually done it where I've machined an angle in there because we had to tilt the part at an angle to machine it, and that was the best way to do it. This was years ago before we had 4th axis and stuff like that. So, but I would still utilize something like that today. So it's really something to it's funny how this is the go-to and it's the cheapest fixture we have. But we do go through a lot of them here. So that's that. I'm going to flip the camera around. I'm going to show some of the other things here. I have a vacuum table that I made years ago. But I'll flip that around and show what we do with that. Okay, here is I think it's a 24-inch, overall 24 by 12. I had made this to make my life easier. At the time, a couple reasons. I didn't want to afford like a Pearson, kind of vacuum table. And I'm sure there's inexpensive ones out there. Well, cheaper than Pearson. But at the time, I didn't want to invest into that because I didn't really know where it was going to take me. So I actually made one, and very successful. I've used this so many times. Actually, it was just on the VF5, and I got this little cheap McMaster gauge and actually colored it in to kind of tell me where my vacuum is good, and where it holds. This connects to the vacuum pump, Venturi pump, and this is this is from my pressure gauge down to the vacuum. So my pressure gauge is here. This is my vacuum pump here. So I have a valve on there, and it actually threaded in. This is also for McMaster if you want. It's a Bimba, and there I believe is the part number. And I also put a valve in here because what happens is sometimes you will break vacuum, or you will get coolant that will go through the seal. And then the easiest way to drain it out is just to open the valve. So let me flip it up. And again, it's a very simple billet piece that actually machined out the back of it and did an O-ring slot and then put a piece of 3/16 50-52 in there. So that's that. And then I'll show you some stuff we have on the 4th axis. The 4th axis is on my Haas VF2. Older unit, 98, 99 model, slightly older. I've done a lot of work to it. If you haven't seen the videos, they are on my channel. I do need to make some more, but some of the stuff I didn't video. But anyway, back to fixturing. Here is a very simple Mighty Bite clamp fixture, spread clamp, dual way. I have it on an ER50 collet platter that bolts to the face of the 4th axis. And with a 36 millimeter crush collar, collet, so we crush it down on there. It makes it so much easier to swap out because I do have different sizes of this. This is one of the smaller ones. I have a 1-inch as well. But in all honesty, for 4th axis to keep everything close, this is probably it's such a huge time saver for modeling as well, because. And I'll show you why, but tolerances stack up. So that's another one there. It's a fantastic thing we use, and it's somewhat disposable. If something happens to it, it's not a big shocker. We just make another one. So I will show you the bigger side of what we're doing with the 4th axis as well. Hold on. So over here, off into the kind of tool crib here, we have a Haas 5-inch self-centering vise. We utilize that often enough, but it's kind of a pain, even with a stop. You really got to walk the part in. And when I say that is you'll put something on there if it's a different op. You're kind of walking your work coordinate system in, or the part where it needs to be in the model. And again, I want to preface this: everything is modeled down to the finest detail, so that you have an understanding of where it is in the kinematic space of what you're doing. And I'll talk about that, but tooling too as well. When you have certain tooling, everything is modeled. Now, obviously the taper isn't modeled. I don't have that in there, but primarily most of the CAD programs are going to have, and CAM programs are going to have tooling you can select. And make sure, and I'm sure a lot of people do not do this, but model it in there. Make sure you have the correct stick out. Okay, all that stuff matters, especially for 4th axis and 5th axis stuff. But even if it's 3 axis, it kind of helps you give a a better picture. So have everything modeled. Have a tool holder there for the tool. Have the correct stick out, the correct tool holder. You can find everything, and if you can't build it, you can build it on most of the software. So here is another fixture I made to actually support the 4th axis vise here, the self-centering. So it locks in, it has 4 bolts here, and then it has an add-on feature here. And I can utilize this. I've actually utilized the ER50 collet holder for that as well, to bolt down here for some of the stuff we do. This is an older fixture, kind of got a little bit beat up, but it did serve its purpose. This is actually a Mighty Bite 1-inch self-centering thing that for the life of me I can't get off right now. But that's an ID clamp. So we would hold 1-inch ID bore tube in that, and then 4th axis mill that. So that worked out really well. So let's go back over to the table and I'll show you one more thing. All right, everybody, we're back over here on the table, and the last thing I wanted to show everybody is, I think, the definition of this video, and that how fixturing can either make or break your shop. What I have here is, it's aluminum 6061, 1-inch wide. That's how it started out as, okay? And the backstory is I had to hold a piece of 15-inch pipe that was machined a certain way. And on that pipe had a couple milled features we had to incorporate into it. Some holes. And to put them in the 4th axis would have fit, but long story short, it wasn't ideal to fixture it in the 4th axis, just due to some, complexities, stuff like that. So this, these pieces all fit together, and to kind of give you an idea, here's half of the fixture. So again, 6 of these pieces, and they're all the same, fit together into one fixture. Now for this job, I had made 2 of them, and the nubs or the tabs here fit perfectly in a mill T-slot. So the part we had a couple external features that we were able to locate on. So once this was all bolted together, and I'll show you how we did that, it was placed into the machine, and then the inner circle diameter here was machined in with some key features for this fixture to help align both of these, 2 solid rings holding the piece of pipe. And what it allowed us to do is, as it's sitting in the table, we mill features. We had to mill them every 60 degrees. So all we're doing is picking up, rotating it, and dropping it back down again, doing some minor indicating in to make sure it stayed in the same spot, and then proceeding with that same operation just 5 more times. So I'll show you here. So what we have this part here, okay, and they fit together just like that, nice and easy. You can see that I numbered them. Hold on, for my OCD people out there, if you can see that, I had them stamped to make it easier if they ever came apart. Now again, they're the exact same part, just one side is stepped up to fit to the other side, which is stepped down. So again, exactly the same part. Okay, and one bolt holds them together. So pretty simple. And again, like I was saying, this is kind of the idea of this video, to show people, to show you guys out there, whether you're an independent guy or you work for somebody, work for a shop, to think outside the box, right? To problem solve and to keep costs down. Now, you might ask, well, why didn't you make this out of one piece? Now, I need it in 2 pieces, so you would have had one here, 2 halves to make a whole, okay? 2 pieces. Just imagine that being out of 1 plate. Now, they don't fit together, so trying to work them in. We estimated about 8 square feet of aluminum plate we would have used to make these if I had to make this out of 1 piece of aluminum. I think less than 1.5 square foot aluminum was used, 1-inch aluminum. strategically nested in, right, to make 12 of these. So to make 2 complete holes. So cost. So cost savings, going back to fixturing can make or break your shop and really show you, standing out. Now, normally this job is long done. I'm normally not a fan of showing my proprietary fixturing, but I feel, it's kind of necessary to help people. Sometimes they see things visually and it opens their mind. It kind of helps them. It might just be a click to them. Like, I could have done it this way. And I'm kind of paying it forward because I've seen that. I've done that. I've seen things like, oh, okay, there we go. So it's kind of helpful. So kind of paying it forward, but really drive the point home of kind of thinking outside the box again, and not necessarily use it for pipe, but you can also do 2 halves of a square. So rectangle, triangle, whatever, where you can utilize it to hold a part. And it's repeatable. You can make it very repeatable. We had quite a few of these to do. So, putting it in the 4th axis wasn't really necessary and very time consuming. And repeatable, yeah, but there's a lot of human error in there. And there could be here, but I think we mitigated that mostly due to the design of this. So, again, it's just time. And again, people running job shops, some of these RFQs, you only get 10, 20 days to do them, if you're lucky. And it just eats up so much time. I spend more time modeling stuff and kind of tweaking some of the programming over and over again, even though it might be 1 of 2 parts, just so that I get in the habit of making it easier for myself and think. And it's going back to where some people don't even have their vices modeled in. They're just modeling off the raw stock, which is kind of silly in my opinion. Not having tooling modeled into your overall design. I mean, simulate everything. Look at everything where you can trim some time off. And it may not be worth it for 1 part or 2 parts, but again, it's worth it overall as you running that machine or running or writing that program or owning a business and doing it on your own. It's beneficial to have everything in the picture so you can see the whole picture. I mean, all these little stupid phrases I'm saying really matter when it comes to the overall job that you're doing, and repeatability for yourself, to have a better quality standard for yourself in the future for the next job. But to kind of close this video out, always trying to think what's the easiest and cheapest thing you can do, but be repeatable and cost effective. Again, the biggest enemy in our industry is time. Customer needs their stuff, and they need it to be right, and they need it sooner than they say, in most cases. So, yeah, that's pretty much all I have on this video. I am on Instagram, The Everyday Machinist, so you can come find me there. I'll try to post some stuff that I can post and do. And yeah, if this has helped anybody, drop a comment, drop a like, definitely subscribe, share the video. Tell me if you want to see any more content like this. And I might make it a thing. It'd be cool to kind of do like a fixture, not a fixture Friday. It's kind of silly, stupid, kind of worn out. But maybe just kind of bring you into what I do and how to create certain things and fixtures that help me solve problems. That's the biggest thing, right? We have to solve the problem. And having proprietary fixturing in your shop, whether it's very simple soft jaws or something as simple but complicated in theory to do, really helps and really kind of separates you from some of the other shops out there, or separates you from some of the other employees out there or contractors. You got to solve problems, and they got to be quick, and they got to be efficient, and they can't take more time to kind of make the fixture than it would be to do the job. And in some cases that can be the circumstance, but you might also, it might in theory be the in your mind the simplest thing to do. But machine time or wise, it may, programming, it may not be the best thing. So don't be overcritical of criticism from other people or opinions. You know how that goes. But just keep an open mind when it comes to this stuff. And hopefully this helped. Again, my name is Patrick, and you're watching Everyday Machinist. Check back for more videos. Thanks again for watching.